In example 19.4, we are asked to evaluate each expression without the use of a calculator. The first statement says log base 3 of 27. I think it's important for us to recognize that this is an expression and not an equation. The definition that we gave for the logarithm and its equivalency to an exponential has to do with equations, not just single expressions. So the equivalency that we had was that if y equals log base b of x, then I can convert that to b to the y is equal to x, and vice versa. I can go from exponent form to log form. But again, this only works because my log is an equation and my exponential is also in an equation. So for these particular examples, we are going to make these expressions become equations. So I'm going to do so by saying, let's let log base 3 of 27 equal something. And I'm just going to use a question mark to represent the answer that I don't know. That oftentimes is reserved for a variable like an x or a y, but I don't want to have too many x's and y's floating around. Let's just call it what it is. It's a question mark. We don't know what the answer is. But if I do this, I can now think of each one of these components that are built into the log statement. 3 represents my base, 27 represents the argument, and then my question mark, which is what I'm seeking, I'm trying to find the answer to this, now represents an exponent. So this gives me a better idea of what I'm really looking for. When I have a log statement, what I'm really looking for is the exponent. So if I rewrite this in exponential form using the definition, I would have 3 raised to that question mark needs to equal 27. And then you can play around with the powers of 3, and you can figure that 3 to the third power is what gives you 27. So that exponent has to be 3. So therefore, log base 3 of 27 must be equal to 3, because that's the exponent that would make this statement true. So that's all a logarithm is representing. It is representing the exponent from an exponential equation. So let's try the next one. We have log base 3 of 1/9. So the 1/9 represents the argument for this particular log. And if I set it equal to a question mark, then I would say 3 to the question mark needs to equal 1/9. So it's really the same kind of problem, but you have to also be aware that your answer could be fractional. It could be negative, could be even 0. I mean, there's a lot of different exponents that we could have. So for this particular setup, we would need a negative exponent. We would need to have -2. So 3 to the -2 is what's equivalent to 1/9. So therefore, log base 3 of 1/9 is going to be equal to -2. It's all about finding the exponent. Let's try the next one, part C. Log base 6 of the square root of 6. We'll say that it's equal to something. And then I will have 6 raised to the something needs to equal the square root of 6. And when we're dealing with radicals, we have to think about fractional exponents. So the equivalency here would be an exponent of 1/2. Exponent of 1/2 is the same as saying the square root. So therefore, log base 6 of the square root of 6 is equal to 1/2. So a lot of what we're doing here is pattern recognition, understanding how to be able to create certain values using exponents. Part D, next one, we have log base 11 of 11. If I set this equal to my question mark and rewrite it I would get 11 to the question mark has to equal 11. And there's only one exponent that will make that true, and that's an exponent of 1. So therefore, log base 11 of 11 has to equal 1. Part E, we have log base 6 of 1 is equal to 0. Set that equal to my question mark, and rewrite to get 6 to the question mark equals 1. And there is an exponent that will make your answer become 1. That exponent is 0. 6 to the 0 has to be equal to 1. So therefore, log base 6 of 1 is equal to 0. And then finally, we have 7 raised to the log base 7 of 23. Again, this is an expression, not an equation. So we can make it an equation by setting it equal to a question mark. Now this is where we're going to run into a different situation, because this is not a logarithmic equation like these other ones are. It's different. If I try to diagram this out, 7 represents the base. The log base 723, that whole log statement right there represents the exponent, and then my question mark actually now represents the argument of a logarithm. So this is not logarithmic form, this is actually exponential form. It just happens to have a logarithm in its exponent. So it's a lot like a composition function. So if I was to rewrite this, I would have to rewrite it as a log. So I start with writing log. My base is 7. My argument is the question mark. And when I write a log statement, it's always equal to the exponent. And the exponent just happens to be another log. And then the only value that I can have in the argument there that would make this statement true is to plug in a 23 for the argument. So then that would make both of the sides say log base 7 of 23. So therefore, 7 raised to the log base 7 of 23 has to be equal to 23.